Hi everyone and welcome to the new video. Meshtastic is an open source of grid communication protocol and it is interesting technology. It allows us to exchange the messages in the middle of nowhere without relying on internet or any other infrastructure. And it is also a mesh network, so nodes will retransfer messages from one to another. In this video I will show a full review of the Heltek V4 board and I will show it step by step from the initial setup and firmware update to configuring private channels, connecting external sensors and so on. I will also do a real test of the board's battery life and I will also do a real range test. Before we begin, a small note. I already reviewed this board in 3 separate videos, so if you already watched all of them you don't need to watch it again. But some people prefer watching long time videos. So if you are new to this channel or you just want to watch a video on a large screen like on a TV, it can be fun to do it. Without further ado, let's get started. Okay, let's see what's in the box. So we can have this Heltek module. As we can see, it's pretty small. It is based on ESP32 board. It has a small screen. The button names are a bit confusing. This button called programming, but actually in Meshtastic it's used as a user button. And this is the reset button and these are all the controls. Also we have this small antenna that I will connect. We have a GPS module and 2 connectors, one for optional lithium battery and second optional for solar power. So technically you can make a solar power node from this. First, there is an important note. Before powering the board and writing the firmware, you need to plug the antenna, otherwise you can burn the transmitter. First, I need to gently push this connector. It's pretty small, but it's easy. As we can hear, it clicks, and now we have the antenna connected. As we can see, this antenna is pretty small, but it does the job. But if you want a better antenna, you can buy it separately. Then optionally, we can connect the GPS. It's also easy. The connector is at the bottom. And now let's turn it on. Okay, when the board is connected, we can flash the firmware. And to do this, we need to go to flasher-meshtastic.org. There are 2 important notes. First, it works properly in Chrome, so browsers like Safari or, I don't know, Internet Explorer will not work. In your system settings, this board must be detectable as a serial port, as a USB serial, of course. We don't use physical serial ports anymore. So you can open your system settings and verify that the port is available, because without port this tool will not work, obviously. So if nothing works, check the USB settings or check your computer and cable. For example, I had 2 Meshtastic boards of the previous generation and it turned out that from 3 cables 2 are not working. So when the cable is connected and device is detectable as a USB port, you select the target device. And for our board it is obviously Heltek. We scroll down and this is Heltek V4. This is the latest board at the moment of writing this video. Then we can select a version. There are different versions like alpha or beta. I am selecting the latest beta. And now we press flash and technically that is it. Here we have the changelog. And as a precaution, I'm doing flash firmware, so I'm sure that the board is completely new. This is my port. As we can see, it is available on the screen. Okay, 5 minutes later it turned out that I get an error because I already wrote the firmware before. In this case I need to plug the board again while holding the programming button. Then the board runs in the programming mode without active firmware and I can try again. As we can see, the port name changed, which is a good sign. Board is in the programming mode. Normally you don't need to do it for a new board, but I already programmed it before. So technically it is easy, but if it is a new board you don't need it. But you may need it if you want to upgrade the firmware, of course, so it's good to know how to do this. And the process is done. Let's test our board. So I disconnected the board from the computer and let's turn it on and I will show how to pair it. This board has only 2 buttons, a reset button and programming button. The name can be a bit confusing, but the programming button is also a user button. There is no joystick here, so we can use this button. I can use it to navigate the menu, and long press used to confirm this, so it is easy. Then I'm selecting the frequency. I live in Europe. As we can see, it's separating long list. And then I use long press to confirm. And the board is restarting now. And here we can see a new available device. Now I can enter this code, as we can see on the screen. So now we're connected to the network. And we can navigate this board using this programming button. Here I can see different nodes. I am using this test in the apartment, and of course there is no GPS log because GPS needs an open area, so I can put it near the window. And we can see all the menus, we can see the configuration, and we are ready to go. Now let's see how we can send and receive messages. Interestingly, most of Meshtastic devices don't have a keyboard, so it is designed to be used with a phone companion, which is technically a good thing, so people can use it like WhatsApp or Telegram, so no special knowledge is required. This off-grid network can be good for hiking, for example. You can just buy a small device, you can put it in the backpack, and then you can just walk and communicate with other people in your group. Interestingly, the phone is only using a Bluetooth connection, so it can be even used in the airplane mode, does not need the cellular network. So practically your phone is only used as a Bluetooth keyboard, and the radio communication itself has a pretty long distance. The message can be sent to several kilometers. And now I will connect two devices and let's see how it works in practice. Okay, at this moment we configured two boards and I will show how the radio communication works. So I am plugging this board. This board at the left is probably 2 or 3 years old. This board is still available and it's a good one for testing. It also has a GPS antenna, it has a battery holder. So here we can see some progress in board's development. This board is probably 2 or 3 years old and this is a new one. Now I have two boards connected. One board has an ID EASC and second board has an ID B62C. I can find this node in my list. So here in the app I can see the list of nodes visible in my location. As a reminder, this is a mesh network, so it is not global, it's not relies on internet. These are the real nodes that are visible in this place. And here in the app I can select a node and I can select direct messages we can see on the screen. As a short reminder of how it works, this phone actually works only as a Bluetooth keyboard. All the communication is done by the radio module. So I can select a node and I can send the message, but message is sent by this small board. So let's do it. And as we can see, it works. I can also use button to switch between messages. So I see this message on the screen here. I can also send another message, well, like 1, 2, 3, 4, and watch the screen. I will also briefly show how to configure the node. So I need to select the node first. It takes some time to get the data. Now I can go to the configuration. Here, for example, we can see the node name. Here we can see messages that I'm using for testing. Another interesting option is position. In the position we have two options, or we can have a physical GPS like this. It makes sense if you want to travel with this board, but if you want to use it at home, you can just enable fixed position and can just enter the coordinates. For example, if I type it like this, I can set latitude, longitude. Other parameters are mostly default, you can check it on your own. Interestingly, an excellent battery life is one of the features that is promoted on the meshtastic.org website, and I've had a doubt that my lab power supply will be able to detect this small power consumption. But surprisingly, it was not the case, and the power consumption was not really small. Anyway, let's connect the board and see how it works. The power connector is included with the board, so I am just directly connecting it to a power supply, and let's turn it on. According to the documentation, the board can work with 1S lithium battery, so I set the voltage to about 3.8 volts and now it boots up. And as we can see, the power consumption is not really small. When the board is working, the power consumption is about 140 milliamps. And we should also keep in mind that this is the idle mode, the board is only receiving the data. And now we can see a peak when the actual transmission is going on. And we can clearly see on the screen that during this peak, the actual consumption is almost 0.8 amps, which is generally a lot. So as I can guess, the real battery life will drastically depend on number of messages you send. I was also curious if turning off display really decreases the power consumption, but it turned out that it's really not significant, and on my power supply I can barely see it. So we can set the display off mode in the settings, but it will not drastically help. And now I will do a simple test. I will connect a lithium battery to my board and I will see how long it will run. So this is my Heltek board and this is the battery I found. This is a good lithium battery, and I read somewhere that the same batteries were used in the Tesla cars, but maybe it's a city legend. So I will insert the battery and will just keep the board running. Of course I must be careful with the polarity. If I insert the battery wrong way, I can damage the board. When the board is running, it sends the telemetry data, which also includes the battery voltage. And interestingly, you can also see it remotely in the app, so you don't need to see it on the screen. So I will just keep the board running, and I even don't need to touch this. I can see the values on the Android app. And interestingly, you can not only see the current values, the app also saves the data to the telemetry log. And now I'm turning the board on. As we can see, it is starting and the initial voltage is more than 4 volts. So I will keep it running and we'll check the log later. Okay, with the magic of the video we can see the results right now. So I was keeping the board running and it turned out that the battery life was about 25 hours. I connected it in the evening, it was about 10 o'clock in the evening, and the next day about 11 o'clock the board was completely dead, so it was not running anymore. So in my opinion the battery life is not exceptional, but on the other side 25 hours is good enough for the full day. So for example, if you're going to the hike, you can use it for the whole day, and if you are going for more than one day, you will definitely have a power supply anyway. So this battery life is in my opinion not exceptional, but it is also not terrible, it's acceptable. And of course I use the small battery. If you want a longer battery life, you can use a bigger battery. And now let's go forward and let's make a range test. Okay, let's do a range test. Generally the process is simple and the range test functionality is already included in the Meshtastic app, but there are some settings that can be tricky, so let's see how it works. To do a range test in Meshtastic, we need to configure 4 parameters. You need to set the channel accuracy, we need to set the location update interval, we need to enable a range test on both boards, and the last but not least, we need to set a sending interval for the board that will work as a transmitter. And now let's do all this step by step. Obviously for the range test we need at least 2 boards. And the top one is a Heltek board. As we can see it has a GPS, so I will take it with me. And the bottom one is the T-beam board. I will use it at home, so it has a fixed position. And the first thing I need to do is to go to the channel settings and to increase the accuracy. Because by default the accuracy is very low for privacy reason and it is about 2 miles. And obviously we need to make this value smaller because 2 miles circle is too large to determine the accuracy. Just keep in mind that the node position is shared within the network, so other people can also see it, but the node is anonymous, so I don't think it's a problem. And you can select a value between 1 or 300 feet, it's good enough. So I need to connect to the node and I need to change these settings and then I can do it on the second node. For the second node that I will take with me, I can also enable the precise location. It will make the accuracy better. And as we can see, the first node has a fixed position, it is okay and I will keep it at home. So this was the first important parameter and now we're going to the second one. I need to open the range test config and I need to enable it for this board. And here I will also set the send message interval to 1 minute. So here the logic is simple, the board at the bottom I will keep at home and it will be sending messages every minute, and the Heltek board I will take with me and it will work as a receiver. And now it is time to configure the Heltek board. First, as I explained before, I need to configure the channel accuracy. I can set the accuracy in feet, or I can set the precise location, it is also fine. Then I open the GPS settings and I set the update interval to 1 minute, so my track will be more accurate. And then I need to enable the range test. The thing is that the range test packets are ignored by default, so it doesn't disturb other people. So to receive the range test packets, I need to enable this setting. And for this Heltek board, I will not set the sender interval, so this board will work as a receiver only. And after changing the range test values, the board will be automatically restarted. As a reminder, we need to enable the range test on both boards. One board will be a transmitter and it will send messages every minute, and the second board will be a receiver. Or if you want, you can use more than 2 boards. This solution is actually flexible. For example, you can configure 2 boards with different antennas to transmit, and then you can compare how many packages you get from each of the boards. And if everything was done correctly, in the long fast channel you will see sequential messages, the numbers will be out incremented. Here we can see the messages from my previous test. And now I will keep the T-beam board at home and I will take the Heltek board with me and go for a walk. It is also important to have the Android phone with you, because this Android app will work as a data logger. While I'm using the board, the Meshtastic app will save all range test packets, and it will also save my position log. And now I will do the test and I will show how can I use this data. Okay, now I'm ready for the test. I will keep a T-beam board at the window as a transmitter. As I explained before, it will send a message every minute. And the Heltek V4 board I will take with me, and the Android app will be saving the log in the memory. And because of the magic of the video, you will see the result right now. So I'm opening the Meshtastic app, I'm going to settings, and here I can export the range test packets. For some weird reason, I don't know why, all packets were exported, but this is not a problem, the number is not too big. For example, if you configured the board to send the packets every minute, you will have about 60 packets per hour. So I just cleaned the CSV manually, or you can do it in Python or in any other language. For example, if you are using bash, this is the command to clean the file. And if everything was done correctly, the output should look like this. And now we have the fun part. We go to maps, we create a new map. As we can see, we can import the layer from a CSV. And this is the file I created. Here I am selecting receiver latitude, and I will use it obviously as a latitude. I am selecting longitude, and I am using as a longitude, of course. And as the last parameter, I can select a timestamp, or I can select signal to noise ratio. It's up to us, or we can select a distance. As a title, I will use signal to noise ratio. And here we are. I live in Amsterdam. I was walking in this area. So this is the coordinates of the receiver, obviously, not of the transmitter. I was walking down the street. At every marker, we can see coordinates and the data. As we can see, the maximum distance between points is about 1.4 kilometers. So technically in the city, the range is not so big. Of course, in the open area, the distance will be higher, but it is still interesting to see how it works. I was walking and the packages were receiving every minute. Of course, you can test it with 2 boards, or you can test it with more boards. For example, you can take 2 boards with different antennas, or you can configure 2 boards as transmitters with different antennas. When the test is done, you should disable the range test on the transmitter because you don't need it anymore. Now let's explore some Meshtastic advanced features. As the first thing, let's see how we can create a private channel in Meshtastic. Obviously, Meshtastic is good for sending and receiving messages, but you don't want all messages to be public. For example, if you are hiking with friends, you don't want everyone in several kilometers to see your messages, right? And in Meshtastic, we can do it easily by creating the private channel. And here I have 2 boards on my desk, and I will show how to create a private channel between them. Let's see how it works. Logically it is simple, but there are some tricks you need to know. Let's get into it. First and obviously we need to open the Meshtastic app and to connect to your board. Then I'm going to the channel settings. The channels list will be retrieved from the board. And now I am pressing the plus button and I am adding a new channel. And here is the tricky part. I need to store the channel name and I need to store the security key. This is important because all messages in Meshtastic are encrypted, and if the name and the key does not match, the message just will not be displayed. So here I am creating the name and I need to copy this key to the clipboard. And now I am pressing save and the channel is created. The UI here is a bit tricky. We need to press send button, and only after that the command to create a channel will be sent to the board. And now we are ready to create the same channel on the second board. Did you remember that we saved the key to the clipboard? So now I'm opening the boards list and I'm connecting the app to the second board. And now I'm doing the same thing. I'm creating the new channel with the same name and with the same security key. So I am pasting the same key and I am pressing save. And again the UI is not obvious. I need to press send again. And now we're done. These two boards are connected to the same private channel. Of course I have these two boards on my desk. If the board is remote, then I can just share this security key with any messenger. I can send it with a paper mail, with a pigeon, with any other way. And now two boards are connected. Let's send a message from one to another. I am opening the conversation window. Here is my private channel. And here I can send the message, for example, hello world. And now I'm sending it. And as we can see, the message has appeared on the second board. The private channel works. Of course, you can add more than two boards to the same channel. The logic is the same. Meshtastic is a decentralized network. There is no central hub. If the key is not correct, you will not see any error messages. You can send different messages, but if the message cannot be decrypted, it will just be ignored. So you need to share the same key for all the boards. And now when the private channels work, let's go forward. Okay, at this moment we are able to create a private channel between two or more boards, and now we will use this channel for the detection sensor. A detection sensor module is a cool feature in Meshtastic, but obviously it works only with private channels, because if you have connected a button or the motion sensor to your board, you don't want all people around to see your messages. Without further ado, let's see how it works. As a first step, I need to open the Meshtastic app. Then as usual, I must select the board and open the settings. And here we have a detection sensor tab. In this window we have several interesting settings. First I need to enable the detection sensor. The second parameter is a minimum broadcast. I will set it to 15 seconds. If the event will be triggered faster, it will not be sent. It makes sense if you don't want to send too many messages, for example if your sensor is broken. The third parameter is called state broadcast. It can be used to send the messages even if the state was not changed. It's a sort of heartbeat, so you know that your board is working. Friendly name is a message that you will see on the screen when this pin changed. You can set any text you want. And the next tricky part is a GPIO pin. Here you must open the datasheet of your board. In theory you can select different pins, but some pins are already used by the system, for example by the serial port. So ideally you can select a pin that is not occupied by any other servers. For example, on my Heltek V4 board I see that the pin 48 is free, so I will use this one. As we can see, the pins list is pretty long, so you can find the pin you want. And the next two parameters will require a bit knowledge of electronics. The first parameter is detection trigger. For example, if my pin is going from high to low, I will select a falling edge. You can test different values and see what works better for you. And the last parameter is input pull-up mode. It is also important. Here the idea is that when a pull-up is enabled, the pin by default is connected to the power, so it has a logical 1. And when the button is pressed, you get logical 0. It makes sense if you are using a button, because if there is no pull-up, the pin will be in the floating state and you can just get electromagnetic noise. In this case, you must enable input pull-up. But if you use a specific sensor, for example a motion detector, this detector usually has its own pull-up resistor, so you don't need to do anything, then you can just uncheck this box. As a first simple test I will use a button, so I am enabling this pull-up resistor, and when the settings are done we must press save. But this is not all we need. There is another crucial settings, and without it will not work. As I mentioned before, we must use a private channel. We must go to the channels page. In here I must select the private channel as a primary, because the board will send these messages automatically and it can do it only for a private channel. I don't know why Meshtastic automatically cannot select the private channel, but we need to do it manually. We need to drag and drop the private channel and we need to put it first in the list. And now I'm pressing send and we are done. So I used a pin 48 and I must connect it to the ground, so it will be logical 0. As a reminder, I'm using a falling edge settings, so I must connect the pin to the ground and the event will be triggered. I just connected two wires to my board and let's see how it works. Of course, in the reality you can use specific sensors for that. For example, maybe you can make a sensor for opening the window or door, but the logic is still the same. Now I have two boards on my desk, and now I'm connecting to the second board. Connection takes a bit of time. And now I'm connecting two wires to trigger the event, and I can see a message on the second board. It works. And by the way, you need to specify a private channel as a primary only on the board that is sending the messages. For the board that is receiving the messages, it is not required. If I press the button too fast, there are no new messages. There was a 15-second broadcast interval. So as we can see, the board works as expected. And now I will show how to connect a motion sensor. The logic is the same. As we can see, a pyroelectric sensor is a pretty simple device. It is a small board. It has only 3 pins, ground, output and the power. You can also adjust the time delay and the sensitivity. And these are all the settings we have. This device is passive infrared. It can detect a human motion. It's not very accurate. Sometimes you can get false positive results, but for this price it's pretty good. Nowadays there are more advanced sensors available, for example 24 GHz micro radars. If you want me to test it, write in the comments below and maybe I will make a separate video. But this passive infrared sensor is good enough for its price. Let's now connect it to Meshtastic and see how it works. The connection diagram is simple. A motion sensor has only 3 pins, a ground, a power and the output. And you need to find 2 datasheets, a datasheet for the motion sensor and a datasheet for your Meshtastic board. As for the motion sensor, it is pretty easy, but I saw 2 different versions. Some boards have a power pin at the left and another boards have a power pin at the right, so be careful. If you connect the wrong polarity, you can damage the board. And here is my motion sensor and here's the Meshtastic board. I need to connect the ground pin. I need to connect the 5 volts pin. And I will use the same pin number 48 as before. The only difference is that I need to open settings and I need to disable the pull-up resistor because the board has its own one. The motion sensor sets pin to high when the motion is detected, so I will use a rising edge as a trigger type, and now we're ready for the test. So generally the logic is the same. I'm saving the config, these are my final settings, and now I can just keep the board running. And when I walk nearby, I can see the message when the motion is triggered. It works. Of course, you can do more adjustment if you want. You can specify the sensitivity, you can change the message and so on. Feel free to test it. And as we can see, the motion sensor works. You can use one board as a remote motion sensor. As we know, LoRa radio modules have a pretty good range, so you can use it on the remote location, for example, for a greenhouse. And obviously the power of Meshtastic is that it is a distributed network. You can have several boards and they will forward your messages. So as we can see, it is an interesting technology. Write in the comments below if you already tested it or if you are going to test. And now let's make a short summary and figure out if it makes sense to buy this board or not. This is the comparison table from the official website, and as we can see, there are some good improvements. This board has more internal flash RAM. For Meshtastic, it can be useful if you save the logs locally. For example, you can enable saving the CSV in the flash RAM. The second improvement is a solar input, so you can use it as a solar node if you want to connect a solar panel. Also, as we saw in the video, the board has a GPS port that can be used. Another good improvement is the higher transmit power. As we can see on this board, it is 28 dBm, and on the previous board it was 21. With the higher output power, when you send a message, you should get a better range. The main disadvantage I see is the power consumption. As we saw in the video, the battery life is not so good. and if it is critical you can find a board with a longer battery life, but generally even with a small battery 1 day is not a big problem, because if you are traveling for a longer time you will need a power supply anyway for other devices. And how can you actually use this board? First and obvious use case is a DIY and experimentation. You can test a mesh network, you can send and receive messages, you can test different antennas, transmitters. This is fun to do it if you enjoy stuff like this. The second use case is an off-grid communication. For example, if you travel with 2 cars in the middle of nowhere, you can use a Meshtastic board in each car to exchange messages between teams, and it can be a good solution for that. The Meshtastic app is easy to use, it doesn't require any specific training, and it works like WhatsApp or Telegram, so everyone can use it. And the third interesting use case is using a Meshtastic board as a radio modem. Meshtastic has a Python SDK, so you can connect a board to the Raspberry Pi or to a different sensor. So in theory, if your sensor is a bit far for Wi-Fi, you can use a LoRa network to send and receive messages. It is also an interesting use case. Also, because it is a mesh network, the nodes can forward messages from one to another. It is interesting to test. If you want to know more, write in the comments below and maybe I will make a separate video. And that is it for this video. Thanks for watching. I hope you learned something new. In the next video I will show more Meshtastic features, I will test networking and MQTT. Press like and subscribe to see more content like this. You are also welcome to visit my Patreon page. Your support helps me to buy stuff like this for testing. Thanks for watching and see you next time.